More and more companies are looking to run their AI agents and systems fully locally, not just for privacy and compliance, but also to reduce their dependency on cloud infrastructure and to cut costs. And the main use case for AI in business at the minute is the ability for staff to chat to agents that are fully grounded in that company's knowledge. One of the best apps that you can use to chat to your documents like this is NotebookLM. And recently, I built an open sourced version of NotebookLM that you can self-host and run on a backend of Supabase and n8n. The project got a fantastic response, and I got a number of requests to create a version that can work completely offline. So that's exactly what I did. In this video, I'll show you a full demo of the local version and a step-by-step guide on how you can set it up. To get this system to run locally, it wasn't just a case of swapping out some models. I had to make some key architectural changes to the backend flows. And the beauty of having n8n operating as a backend is that there weren't any code changes needed to the front-end app. So absolutely everything here runs locally, and a big shout out to Cole Medin. This local version of InsightsLM is built on the incredible work he did in creating the local AI package. And I've published a new repo on our own GitHub account, which contains the files that you need to get this up and running. Let's dive into our fully local version of InsightsLM. So you can see that this is running on localhost port 3010, and that is just one of a number of containers that we have up and running on Docker desktop. So you can see there, InsightsLM. We have a backend of both Supabase and n8n, and all of this is contained in this package. So we have our various Supabase containers. We have n8n running on port 5678. And then for LLM inference and embeddings, we're using Ollama. For audio transcription, we have a Whisper container, Whisper ASR. And we're also using Coqui TTS to generate our podcast for our notebooks. So if we create a new notebook here, so let's upload some sources. So we'll click Add. And let's upload our 180-page F1 regulations document. So I'll drag that in here. And you can see that it's now generating a notebook overview as well as embedding that actual document into Supabase's vector store. And if we jump into Docker, you can see that Ollama is starting to kick off. The CPU usage is maxing out. Fan spin is kicking off as well. And we have our overview back with a nice little icon. And then also the embedding process is continuing. And that is now completed. And we have our sample questions that we can ask of this notebook. So from an n8n backend perspective, what happened there was we triggered the generate notebook details workflow. And this workflow essentially generates the title and the description, as you can see here. And we have different types of sources that can be uploaded. So because this was a PDF, it went down this track. Whereas if it was a URL that we added, or we just copied in some text, it would have come up here. And then we hit Ollama with the generate title and description node, and we generated a random color for the actual notebook on the homepage. And if we jump into Ollama, you can see that we're using the Qwen3b 8 billion parameter model with quantization 4, and we're getting a JSON output that we have defined here in the structured output parser. And then we just update the row off the back of that, which updates the front end. And then the other workflow that triggered was the upsert to vector store, because we just sent in that 180-page document. And if we go to executions, you can see it took 56 seconds, which isn't too bad based off the smallish GPU that I have. And if we dive in, we can see that it generated the title and description. And from looking at the timings here, this was the longest part of the process. This took 39 seconds because that 180-page document was loaded into Ollama's context. And from there, the notebook title and description was saved into Supabase, and then we embedded the document across 674 chunks. And this process, let's have a look. Yeah, it took about 8 seconds to actually embed using the nomic embed text model. So I think that's a pretty decent performance. And then we have a callback URL off the back of that to update the icon. Cool, so we have our document embedded. Now let's ask a question. What are the minimum mass requirements for F1 cars? And asking this question is going to trigger our chat workflow that you can see here. And you can see that has just succeeded. And there's our answer. The minimum mass requirement is 800 kg. And if we click on the citation, it should bring us to that exact section of the document, which it does. And you can see the mass of the car must not be less than 800 kg. So that is correct. And if we look through this workflow, what we're doing is we're fetching the chat history. We're injecting that into a simple prompt into Qwen3 to generate a search query that we can then go to the vector database with. And from there, we're going back to Ollama with those chunks to generate a response. And then there's a bit of processing for our citations. because Ollama is only providing a very simple way of citing its sources. So we then build that out into a complex JSON structure and save it all to Supabase. And then it's rendered, as you see here, with clickable icons that you can jump to the correct section. And if you've seen the previous version of InsightsLM, you'll know that this chat flow has changed pretty significantly. So this is the cloud version of the chat flow, and we're simply just hitting an AI agent and we're rendering out the response. I had to completely re-engineer this for local LLMs, because here we're using a frontier model that has hundreds of billions of parameters, that has a reasoning capability, and it has the ability to produce a highly complex output structure that you can see here. Whereas, because I'm using an 8 billion parameter model locally, it really doesn't have the sophistication to actually output like this. So instead, I broke down the process to the point where it actually reliably produces responses as well as citations. So let's ask another question. What is the Planck assembly? So that's now triggered the chat workflow again, as you can see, succeeded in 17 seconds, and we get a detailed answer, and it is correctly referencing the Planck assembly section of the documentation. Let's ask it another question to try to get a longer answer that references more than one section. Can you give me an overview of the various rules in the document? This is a tricky question for an AI agent linked to a vector store to answer, because vector stores only return a set number of chunks, whereas an overview or a summary typically requires the full access to the document. Now, you could have a dynamic number of chunks that are returned from the vector store based on the type of question, and that's something I'm thinking about playing with in the future. Okay, so this question has taken a while to answer. You can see we're at the 1.5 minute mark here, and the fan is spinning like crazy. So I don't know, is Ollama caught in a loop here? I'm possibly loading in a model that's probably a little bit too big for the actual hardware that I have. I'm running this on a NVIDIA GeForce 4070, which has 8 gigs of VRAM, but that's possibly not enough for a 7 billion parameter model. And yeah, I can see errors here around the GPU VRAM usage didn't recover within the timeout. And this gets to the heart of running local models with Ollama, that they do really need to fit to the hardware that you have. So I've just stopped this one because it wasn't going to succeed. If I clear down the cache here, and let's ask that question again. Yeah, this time it was able to succeed within 11 seconds. Sometimes we just get a wall of text as an answer. Here we've got quite a detailed answer with lots of different citations, all linking to various relevant sections of the document. So the system prompt for the Qwen 3 model could be tidied up to try to get a more consistent output. But then it is also down to the prompt adherence of such a small model and how well it will actually follow those instructions. If we look at the chat system prompt here, I've dramatically reduced the size of the system prompt compared to what we have on the cloud version, because we definitely need to simplify things for an 8 billion parameter model. If we look at some of the other features and how they work locally, if we click on Add Sources, we can drop in an MP3 file, and this uses the Whisper transcription container. So if we jump into Docker, we're sorting by CPU usage here, and you'll see Whisper ASR has just popped to the top. And if we click into it, you can see the summary, as well as the full transcription of that MP3. So what powers this in the back end is this process additional sources workflow, which essentially triggers our extract text sub workflow, which is this one here. And this is where we have our local Whisper. And if we click into it, you can see that we're hitting the Whisper ASR service on port 9000, and we're passing the binary data of the MP3 that was uploaded. So that works pretty well. And this could, of course, be built out to accommodate other file types. Currently, we have PDF, audio files like MP3s, and standard text or documents. As well as MP3s, you can provide URLs that can be scraped. So let's grab a couple of URLs from Formula One's website. So that's the 2025 schedule, and there's the results. So if we add these two websites, and the first one has succeeded. So we have our summary, which outlines the races, as well as the entire markdown of that page, and the race results is finished as well. So other types of NotebookLM features, you can save notes, as you can see here. You can add additional notes to keep track of whatever it is that you're discussing. And then also we have our deep dive conversation. The quality isn't as good as Gemini's text-to-speech. We can only really support a single speaker. But if we click on generate, this can take a few minutes. But what it's doing is it's triggering our podcast generation workflow. And again, there has been modifications from the cloud workflow that you may have seen in the previous video. And here what we're doing is we are actually truncating the sources because we are on limited hardware here. We then go to Ollama to generate a transcript to then be outputted, uploaded, and made available on the front end. And there we go, we have our deep dive conversation. So let's give it a listen.
Do you ever just stand there, watching a Formula 1 car tear down the track, and wonder what the hell keeps it from just flying off into the sky? I mean, it's got wings, right? But those aren't just for show. They're part of a whole damn blueprint, a set of rules that have been tweaked and tested for years to make sure everything works just right.
That's pretty good, actually. It's definitely more robotic than a lot of the frontier models like 11 Labs or Gemini's text-to-speech, but not bad for something that's running in a Docker container. If, like us, you'd like to dive deep into AI and automation, then check out the link in the description to our community, where you can join hundreds of fellow automators, all looking to leverage the latest in AI to automate their businesses and get ahead in their careers. We'd love to see you here, so check it out below. To get a fully isolated and private version of InsightsLM set up and running on your local machine, the first step is to go to Cole Medden's local AI repo, which I'll link in the description below. This is an incredible self-hosted AI package that includes everything we need, such as n8n, Supabase, and Ollama. So again, massive shout out to Cole for creating such an amazing resource, and it's great to be able to build upon this. And within this documentation, there's full installation instructions to get this package up and running. For InsightsLM, we do have our own local package, which you'll also need to clone and bring in some of these files into the main repo. So I'll talk through it step by step. And the first step is we need to clone Cole's repo and essentially download all of these files to our local computer. And before we get started, there are some prerequisites. You need to have Python installed, you need to have Git or GitHub Desktop, and Docker or Docker Desktop. And then you can either use a terminal or you can go into an IDE to get this set up. I'm on Windows here, so I could use PowerShell, for example, but instead I'll set up the project in VS Code. This is free to use, and if you haven't used a development environment before, I definitely recommend setting it up. It can look intimidating, but it really can speed up the process when you actually get familiar with these types of tools. Within VS Code, you can just click Clone Git Repo and just drop in the URL of the repo you want to clone. And when you click Enter, you can choose where you actually want to clone that repo on your machine. So we'll just choose this My Projects folder. Great, so I can now see the files in the repository, as you can see here. So next up, we're going to clone our own InsightsLM local package into this folder, and then we can start working with the files. So for this, if you click on Terminal and just open up a new terminal, and then just type git clone, and then copy out the repo address, which is this one. And then that will create a folder within Cole's AI package that contains all of the files that we need. We next up need to make a copy of the env file and set some environmental variables. So that's the env.example here. So we'll just Control-C, Control-V, which then duplicates that file. F2 to rename. And then we can just call this .env. And from here, we need to start setting some secret keys, as you can see on screen. And Cole has documented the specific secrets that you need to update. There are lots of ways to generate secure passwords. For the moment, I'm just going to use a service like LastPass, and I'll just set the password length to quite high and turn off symbols. So I've dropped in the two n8n secrets and the Postgres password. For the JWT secret, along with the anonymous and service role keys, check out the documentation that's listed here because these need to be auto-generated. So I'll just drop in another key into the JWT secret, and when you click generate, that'll give you the anon key. So we can copy both of these out. And then if you choose service key and click generate again, that'll give you the service key. And this is why using a development environment like VS Code makes a lot of sense, because it's very easy to just make changes and you're not messing around in notepad files. So I'll set a database password. And then for pool or tenant ID, you can see that that can be any value like 1000, which is what I'll set it to. For Neo4j, we're not actually using it in this project, so I'll leave it as is. And that's the same with the Langfuse credentials below. So now that we've set these environmental variables, let's now go into the InsightsLM local package, and you'll see that there's a .env.copy. So if you click on that and just copy out everything that you see there, we're going to drop it in at the very end of this file. And here we're saving the URLs that the Supabase edge functions are going to be hitting to generate embeddings or chat completions. There's also environmental variables for the Whisper service, for transcribing audio into text. So there's one more key that's left, which is this notebook generation auth key. And this is the key for the webhooks. Now, this is less important in a local environment, but still it's good practice to set it. So I'll just pick up another key and drop it in. Okay, so that's all of the environmental variables for the local package and then also for InsightsLM. Next up, we need to make a couple of changes to the Docker compose file. So on the left-hand side here, if you click on docker-compose.yml, and then also under the InsightsLM local package, if you click on the Docker Compose copy file, you'll see that in the copy file, we have a few things that we need to add to the main Docker Compose. So the first one is we need to add a whisper cache as a volume. That's at the very top. That's that one there. And then under services, we need to add these three services: InsightsLM, Coqui text-to-speech, and Whisper ASR. Now, both of these models are configured to use a GPU. So if you are on Apple Silicon, for example, you will need to change these profiles out. I'll leave a note in the documentation for that. Okay, so we'll just copy these services. Don't bring in the word services, it's just the three individual ones. And then into the Docker Compose file. And then if you scroll to the very bottom, you can see all of the services that are listed. And we'll just make some space and paste in the additional services. Okay, and you can Control S to save. So this is the definition now in place so that we can spin up containers for all of these services. And one last small change I'll make to this Docker Compose is that Cole has Quinn 2.5 listed as the model. I did change this to Quinn 3 when I was actually building the project out. So I'll just paste that in there. This is the 8 billion parameter model, quantization 4. And this is pretty much at the very limit of what my NVIDIA GPU can handle. So we'll save that, and we're now at the point where we can actually trigger these services to run. So if we go back to Cole's documentation, he has a start services Python script, which is what we're going to be using. And as I said, I'm on a NVIDIA GPU, so this is the command that I'll be using to actually spin up all of these containers. Okay, so back to VS Code. And before I put in the command, let's just open up Docker Desktop, which is here, and I have no containers running. So now I'll just paste in this command and click enter, and that starts downloading the images and then spinning up the containers. Now this can take a while because there's the guts of 30 gigs worth of data to download between the various container packages. And that's all of the Supabase containers initialized, and it's now downloading the InsightsLM codebase and spinning up that container as well. Okay, so we're up and running. So then if you go into Docker Desktop, you can see all the containers that are up and running. So against all of these containers, you can see that some of them have exposed ports that you can access in the web browser. So Supabase Kong is the main entry point into the Supabase Studio dashboard. So if you click on that, it'll load up. Now I have found that this can take a couple of minutes to initially load, but then once it does, it's lightning fast. So we have our authentication, and I did set the password in this env file, so let's dig it out. Dashboard password is that one. So just paste that in, and there we go. And once you're in, if you go to the table editor, you can see that there's lots of tables already in place. And that's because the n8n container is using Supabase as a Postgres database for it to run. So this is now the full backend of n8n, as well as being the backend for InsightsLM when we get it set up. Next up, open the Supabase migration script that's in that InsightsLM local package folder. This has the full definition for setting up the various tables and policies and storage buckets. So press Ctrl-A to select everything and Ctrl-C to copy, and then go to Supabase, click on SQL Editor, and then delete out whatever's there and press Ctrl-V to paste the migration script, and then click Run. And once you click Run this query, it'll set everything up, and then you should get a success, no rows returned result, which is what we see here. So at this point now, if we go to storage, we can see the buckets that the app requires. Within the database, you can see the likes of the documents table, the notebooks table, the notes table, etc. So now that we've spun up Supabase, if you come back to VS Code, if you open up the Supabase folder and then open up volumes, there's a functions folder, and you'll see two default functions in place. So what we now need to do is move across the functions for InsightsLM into this folder. So if you go to InsightsLM local package, Supabase functions, and I have all of the functions listed that we need for the app to work. So just hold Control on your keyboard and pick all of the folders that we want to move. And then we just need to drag them into the functions folder itself. And now you can see all of these functions are now available within Supabase once we restart the container. And there's one other change we need to make, which is in the Supabase Docker folder. You'll see that we have a Docker Compose file. And we need to make a few changes to this. Now, I'd rather not do it in the Docker Compose file because that will be overwritten the next time there's a new version of Supabase that's pulled down. I tried for hours to get a Docker Compose override file working and failed. So if there's any Docker experts that are watching this that know the problem, let me know in the comments and I'll update the documentation on GitHub. But for the moment, if you scroll down to the functions service, which is this one here, you can see that there are environmental variables that are being declared for this container. So we need to give this service access to our own environmental variables so that when the edge functions are triggered, they know which n8n URL to actually hit. As well as an override file, I tried to drop a .env file in the functions folder. That didn't work for me either, so I'm not sure what's gone wrong with it. But for this, if you open up the InsightsLM local package and then click on Supabase Docker Compose, these are the environment variables that we need to drop in. So just copy those out and then just paste them in underneath the verified JWT and just tidy it up. And that's it. So now the function service will have access to our URLs because these are all in the .env file when the Supabase container is being spun up. So with those changes made, let's just spin down the services and we can restart them. And we do have a command in Cole's documentation on how to stop all services. So I'll just copy that out. Now you do need to put in your profile. So I have an NVIDIA GPU, which is that one. So click enter and then that'll shut down everything. And we'll just spin up the services again by triggering the start services script. And then these environmental variables will be made available to the edge functions. All of our services are back. So you can see we have access to our Supabase dashboard again. We can access n8n at port 5678. And from here you can set up an account, but this is really only being saved in your own Supabase instance. And once you're logged in, click create a workflow. And then on the top right, click import from file. And then go to the InsightsLM local package, click on n8n, and then choose this import workflows file that you see on screen. And that loads up like this. And from here, then there's a couple of changes you need to make before you import all of your workflows. So the first one is you need to update this node. So here you need to add an API key. So for that, if you go to your account on the bottom left, click on Settings, n8n API, and click on Create an API Key. Give it a label and click Save. And then you can copy out your local n8n API key and then bring it back in here to create a credential with it. So paste it in there and then just copy in the base URL. So for me, it's localhost or 127.0.0.1/5678. And then you need to type in API-v1 and click Save. And then you'll get a green success message. So that's the first thing. And then on the left-hand side here, there's this enter user values node. Here we need to enter our Supabase credential ID, our custom webhook auth to authenticate the pinging of the web services, even though they are local. And then we need to enter our Ollama credential ID. So for this, if you go back to overview and on the top right, click on create credential. Firstly, we'll set the header auth. So choose that and click continue. For name, you need to put in authorization. And then the value is what you saved in your .env file, which is this one here. And once you save it, if you click on details, you can see the ID of this credential. So just copy that out and then bring it into your user values. And this is the second one for our webhook header auth. And then back to credentials and then create a new credential. This one is Supabase API. Click continue. And for host, we need to drop in Kong port 8000 because that is the internal container name for the Supabase gateway. And service role secret again is in our .env file, which is this one here. And when you click save, you'll get a green success message. So we'll grab the details of that as well. That is our ID. So that one goes in there. And then finally, we need the Ollama credential ID. So we'll create a new credential, Ollama. And the base URL for this isn't localhost because the n8n container can't access the Ollama container via localhost. So the service name within that Docker compose file is Ollama. So if you click save, it can then access it via that name. And we'll copy out the ID for that. Okay, so we have those three values set. So now we can just click execute workflow, and then that automatically downloads the 6 files we need and imports them into your instance. So now if you come back to overview, you can see that you now have all of those workflows set up. And if you jump into any of them, for example, you can see that they're now fully connected to the credentials that you set. So there's no errors being thrown here. And the same for Ollama, that's connected to that credential. And all of these webhooks have the header auth credential set as well. So this makes life a bit easier when you're importing these workflows. So what we'll do is we'll just activate these workflows. So you activate all of them except the extract text one. You no longer need the import workflow, but we'll just leave it there for the moment. And if you look for InsightsLM, which you can see here, you can click on the port. So this is port 3010, and then that opens it up here. Now you need authentication. You need to be able to log in. So for that, go to Supabase. So that's port 8000 for Supabase. And within Supabase, if you go to authentication and click add user, you can create a new user. So at this point now we can log in, and this brings us into our dashboard. And from here you can create your first notebook. So click on the button and then you can add your sources. So I'll click add and let's just drop in a couple of PDFs. I'll drop in my usual document, which is the F1 regulations. So that way I can have a sense of if we're getting good results back or not. And I can hear the fan spin on the laptop as Ollama is kicking off, crunching the numbers. We have the notebook overview back straight away, which that was pretty fast. And there we go, the chunking is finished and this document is fully embedded. And by clicking on it, you can see a summary of the document along with the full document itself. And then let's ask it a question. What is the Planck assembly? And that has gone to the n8n chat workflow. Again, I can hear the whirl of the fan. Okay, and there's our answer, which looks quite detailed actually. And we have our citations as well. So let's test it out. If we click on this one. Yeah, perfect. Planck assembly. That's brilliant. And that talks about the floor bodywork, preventing air passage between it. So yeah, that is a very good citation. Let's test out the whisper transcription. So let's upload an MP3 and we'll drop it in here. That is currently processing. And if we go to Docker, we can see that the whisper ASR container is at max CPU usage. And we can see that a post has been made to it. Okay, and we've got a green tick, so that means it has been transcribed. And there you go, yeah, that's exactly it. So now let's test out our deep dive conversation. So we'll click generate here, and this will then trigger the Coqui TTS container. So we should see this one pop up now. This n8n blueprint uses Ollama initially to generate the transcript, so that's what's running here. And now that's dropped down and Coqui TTS takes its place, and it looks like it's finished. So let's have a listen.
You know what's wild about the 2025 Formula 1 technical regulations? It's like getting a front row seat to the blueprint of the fastest machines on the planet, and it's packed with rules that are both incredibly detailed and surprisingly flexible.
That's pretty good. It's definitely not as good as NotebookLM's two-way conversation, and this is specifically a single speaker, but it's still not bad for a fully local model. So there you have it, a fully local NotebookLM clone that you can run in complete isolation within your network. And while it might not have the sophistication of some of the frontier models available in the cloud, you have total control over both the back-end workflows, along with locking down your data from a privacy perspective. Thanks for watching, and I'll see you in the next one.